Hello everyone, thank you to take part in my presentation. I'm a PhD student in the engineering department. We are working on malaria detection. Who knows how many people die from malaria around the world each year? It is one of the most common infectious vector-borne disease around the world with 200 million clinical cases and 400,000 fatalities a year. It transmits to humans by mosquito in poor countries with poor infrastructures. Unfortunately, current technologies, including microscopic observation of blood smears and polymerase chain reaction method that they are based on DNA, are costly and time-consuming. I can also mention two antigen-based detection that they are known as rapid diagnostic tests. They are fast and cheap, but the threshold sensitivity is near 100 parasite per microliter, which can't detect early stages of the infection. To find a solution for this problem, we paid attention to blood streams. We found that malaria parasite digests the hemoglobin of blood during infection, and during this process, low spin Fe ions change to high spin paramagnetic Fe ions that has magnetic properties. During this process, a byproduct called hemozoin will appear, which has magnetic properties compared to healthy blood cells. Here in ETS, we designed very sensitive and fast response magnetic field sensor employing photonic crystal fiber infiltrated with ferrofluids. It is a liquid containing magnetic particles. When we exerted magnetic field to the liquid, magnetic particles are agglomerated and form a chain-like clusters along the direction of magnetic field. So the refractive index will change and we can detect the signal. We want to use IDEA to design a very cost-effective sensor. We want to replace photonic crystal fiber with capillary fiber, which is very cheaper and easy for designing. And instead of ferrofluid, we want to use infected blood cells. In here, we can see that when we exert magnetic field, the infected cells directed along the direction of magnetic field. And so this sensor works based on refractive index variation in terms of optical response. And we hope to be able to design cost-effective with fast response sensor that will save a lot of life in poor countries. Thank you for your attention.